A question like this is relying on a concept called cofunction angles. So let's talk about what that really means here. So the information that we currently know is that the length of AB is equal to the length of BC. So let's go ahead and mark those as congruent. And then it's asking for the value of sine from angle CBD. The most important letter is the middle letter. That's always the vertex. So CBD really means angle B here, which we're going to call it angle 1. And I'm going to put that right here so we don't get confused. And they're subtracting cosine from angle BAC. So again, that second letter is the most key. So BA, they could have called it BAD or BAC. It's really the same angle, angle A, which we're going to call angle 2 here. So a couple things that we know for sure. Because of the fact that this is 90 and these two angles form a linear pair because they're right next to each other, they're supplementary, meaning that this must also be 90 so that they add up to 180. The other thing we know is if we go to page 34, specifically the back side of it, so side 4, where all the geometry concepts lie, we know that triangle sum theorem says all three angles in a triangle add up to 180, but also the corollary is really important. It's basically saying that if one of the angles is 90, so if it's a right triangle, the other two angles are complementary, so they add up to 90. So since this angle's 34 and it's a right triangle, we could do 90 minus 34 and we get that this angle up here is 56 degrees. Now we also have a concept called base angles theorem. And what it says is for an isosceles triangle, the angles opposite them are congruent, so the angles at the bases. So then this is also 34, and then if we do 90 minus 34, of course, again, we get 56 degrees. So now let's go ahead and apply SOHCAHTOA, so sine, cosine, and tangent to this scenario. They say sine from angle CBD, so from angle 1, we'll say, opposite, let's call it x, over hypotenuse, which is up here, the one across from the right angle. So let's say that's x over y, minus cosine from angle BAC. So from here, cosine's adjacent over hypotenuse. If ever you're confused about which one's adjacent, I always like to label first opposite, then the hypotenuse, which is the one across from the right angle, and by default, this one is adjacent. So if we do adjacent over hypotenuse, because of the fact that this is x right here, and we've established that these triangles are congruent, you know that this is also x, and then the hypotenuses are congruent as well, as we established at the beginning, so we'll call that y. And so if we do adjacent over hypotenuse, we get the same thing. And the key concept there is that the sine of any angle is equal to the cosine of its complement. So in this case, sine from 6 degrees is equal to cosine of 90 minus 56, in other words, 34 degrees, which was right there. So we get our answer when you subtract anything minus itself as 0.